We'll continue looking at our exponent rules, and sometimes we have to deal with a negative exponent. So if it is already a negative exponent, we actually have a definition. It will switch to the denominator and become a positive exponent. We'll look at several examples here that are just applications of our definition. First one, we have x to the negative fifth power. It is going to shift to the denominator and become x to the positive 5. The next one is exactly the same. X to the negative 4 become 1 over x to the positive 4. Third one will become 1 over a to the positive 2. So if something has a negative exponent, you shift it to the opposite place and change the exponent to positive. You always have two changes together. All right, let's look at these other problems. Now you have to watch to see what is the negative exponent really with. Right? It is only with the a on this problem. So you're going to keep the 8 exactly like it is, but the a is going to shift down to the denominator and get a positive 8. Right? This one. Right? The 5 is going to stay just like it is. That exponent has nothing to do with the 5. So we'll keep the 5 and we will get a to the positive 6 in the denominator. I'm going to rewrite the other two. So if I have negative a to the 8th, right, this piece is going to be left exactly like it is. You do not shift for a positive exponent. The sign of the coefficient can be negative. That doesn't matter. You will leave this one exactly like it is. So it stays. Right? And our last one, negative a to the negative 8. This is like a negative 1 in front. So it is going to stay, but your a is going to move down to get a positive 8. So then you will have to write a 1 in the numerator. This problem could actually be done two ways. You could subtract exponents top to bottom just watching your sign rules, or we could shift these. Basically, if I already have a fraction, I'll go ahead and shift. If I do not have a fraction, I'll save the shifting until last and do the other work first. So I'm going to go ahead, and these will actually just switch places. The x to the negative 4 will go down and become a positive 4. The x to the negative 2 will go up and become a positive 2. So we'll have x squared over x to the 4th. When we have positive exponents, we said you could think of the picture. You have 4 x's on bottom and 2 on top. Just subtract biggest minus smallest. It will stay wherever you had the most x's. So you're going to be left with 1 over x squared. If you chose to subtract top to bottom, I want to just show you how it would go. I would tend to write that if I was going to do it. So I have x to the negative 4 minus, is your rule, a negative 2. And then you have to watch your signs. This will make a plus. So you have negative 4 plus 2 will give us x to the negative 2. And then we can do the shift. So you can work either way that you like there to clean up those negative exponents. For this example, you are going to shift to the top because the piece that you have that has a negative exponent is in the denominator. So it is going to go up. There is no reason to move the a. So the a is going to stay right where it is. The v will move to the top and get a positive exponent. For this example, since we are already in a fraction form, I'm going to go ahead and shift everything that has a negative exponent. So I'll circle the ones that will shift. Everything else will stay where it is. So 9 over 15. The a to the 4th stays because the exponent's positive. The a to the negative 6 goes up and becomes a positive 6. The c's are going to switch places and get positive exponents. And the d's are just fine like they are because they already have positive exponents. Right? And now it is like 4 little problems. So we have numbers, which will reduce. A's, C's, and D's. So for our numbers, we have a common factor of 3. So 3 will go into 9 3 times. 3 into 15 will go 5. Your A's are side by side. Your rule is keep the base and add. So it will give us a to the 10th. For the C's, we can think of the picture. We'll subtract biggest minus smallest. So 6 minus 4 will leave us 2 C's on the bottom. And the D's we can subtract. We have more D's on top. So we will have D to the 5th. For this example, actually every single piece has a negative exponent. So they're all going to just switch places. So everything that's on the numerator is going to the denominator and the exponents become positive. Everything that's on the denominator goes to the numerator and the exponents become positive. And that's D to the positive 1. Right. For your numbers, you have to actually raise them to the power and work them out. So 3 squared will give us 9. 2 cubed will give us 8, and that does not reduce. For the x's, we'll do biggest minus smallest. So 4 minus 2 will leave us 2 x's on the denominator. For the c's, 5 minus 2 will leave us 3 c's on top. And for the d's, 4 minus 1 will leave us 3 d's on the denominator. If you have a fraction to a negative power, you can just flip the fraction and change the exponent to positive. And then work it like normal. That exponent will go to the numerator and to the denominator. So 2 squared over 3 squared. 2 squared is 4. 3 squared is 9. Here's another example with a negative exponent on the outside of a fraction. So it will apply to the whole fraction. We can go ahead and invert the fraction. So the 5y will go up, the 2x will go down. The outside exponent becomes positive. And then you can take it with the numerator and the denominator. So 5y to the third over 2x to the third. Remember that 3 does apply to each piece there. So we have 5 to the third, y to the third. And we have 2 to the third, x to the third. 5 to the third is 125. And y to the third. 2 to the third is 8. And an x cubed. If there is anything inside the parentheses that will simplify, you should do that first from the inside out. So for this problem, we're just going to stay on the inside first and keep our parentheses. The 3 over 4 does not reduce, so we'll just leave it like it is. For the x's, this x will shift down, so we'll get x cubed, and we have 1x down there already. The y's are going to switch places. And we still have a negative exponent on the outside. Now let's finish cleaning up on the inside. So we have 3 over 4. The x's are side by side, so the rule is keep the base and add the exponents. Don't forget your 1. Right. The y's will subtract. It's going to leave y to the first on top. And now we'll deal with that negative exponent on the outside. So everything inside is cleaned up. We'll go ahead and invert the fraction inside and change the outside exponent to positive. So everything inside is going to flip. And the outside exponent becomes positive. So the 2 will now apply to the numerator and to the denominator. So we're going to have 4 squared, which is 16, And this is x to the 4th squared. Remember, that'll be a power to a power. Keep the base and multiply. And the 2 will apply to each piece in the denominator. So 3 squared will give us 9, and it will just be y squared. Sometimes it's easier to just go ahead and apply the power rule, especially if you don't have a fraction form to begin with. So I would go ahead and do that. It is a power to a power. Your rule is keep the base and multiply the exponents. So it will give us x to the negative 4, and then I would switch it to 1 over x to the positive 4. For this problem also, it's a power to a power. I would keep the base and multiply, which will give us x to the negative 18, and then I would switch it. So 1 over x to the positive 18. For this problem, there is more than one way to do it, which both techniques are fine. You could simplify inside first. All those are going to switch and make them positive. And then your outside exponent would say, okay, invert your fraction, so you're going to flip them again and change the outside exponent to positive. That's one way to go, and that's the way we've been going with the other problems. Just because of this, how this problem is, because all of these are negative and the outside is negative. If you wanted to go ahead and do your power rule, because it's going to be a power to a power, so x to the negative 4, y to the negative 8 to the negative 4, and a to the negative 3 to the negative 4. When these multiply, they're going to make the exponents positive. So this will be x to the positive 16, y to the positive 32, and a to the positive 12. It only worked out so nice like that because everything had a negative exponent. So go with whichever way you are most comfortable there. This problem also has 2 different routes you can go. You could clean up inside first and then apply the outside exponent. Because everything inside has a negative exponent and outside is a negative exponent, we'll go ahead with the power rule. So x to the negative 6, y to the negative 3. That's all to the negative 5th. And we have z to the negative 2 to the negative 5th. And these will be power to a power, so we'll keep the base and multiply, which will give us a positive 30, a y to the positive 15, and a z to the positive 10. This problem has 2 or 3 different ways that you could go. You could clean up inside, move your y to the negative 6 to the numerator, and then apply your product to a power. You could invert inside. The exponents would stay exactly like they are, and the outside would become positive. Or you could go ahead and just do a power to a power here. So this outside power would go with the numerator and the denominator. So have x to the 7th to the negative 7, and y to the negative 6 to the negative 7. Power to a power, keep the base and multiply. Gives me x to the negative 49. And I'm going to get y to the positive 42. The x will now need to shift down. The y is going to stay because it already has a positive exponent. So I have x to the positive 49, y to the 42. Those are on the denominator. When everything goes out of the numerator, remember to write the 1. For this problem, also several different ways to do it. I'm going to go ahead and just take the outside power to each piece. And power to a power, keep the base and multiply, will give me a to the positive 18. And down here I will get c to the negative 12. The c will need to move up. So the a is staying on top. The c will move up. There is nothing left in the denominator, so I don't have to put 1 in the denominator. For this next problem, there certainly is more than one way to do it, and it's going to be a multiple step problem. we would need to take care of getting the parentheses off. I am going to choose to shift the entire first parentheses to the denominator for this outside exponent. Before I rewrite it, notice with the first parentheses there is no exponent outside, so there really is no need for that parentheses once the other one is moved. So I'm going to have 8 x to the 9th y to the 6th. This one's all going to the denominator. And I still have the parentheses there. The outside exponent becomes positive. Now, I need to work out that denominator. So the 2 will apply to each piece. So I'm going to have 7 squared, means 7 times 7 is 49. You have to remember that with numbers to a power. For variables, you multiply. So it will be x to the 8th and y to the 16th. Right. Now I'll work with my problem to simplify anything that I can. So I really have 3 little problems. My 8 over 49 does not reduce, so I'm going to leave it just like it is. My x's, I will keep the base and subtract. I'm going to have 1x left on top. For my y's, I will do biggest minus smallest. 16 minus 6 will leave me 10 y's on the denominator. We have one more exponent rule that is a definition, and this is something to the 0 power is equal to 1. What you have to watch with this is what is the 0 really with. So we'll look at a few examples. The first one is just a straight application of the rule into the 0 is equal to 1. The second one is also a straight application of the rule. 5 to the 0 is 1. The third one, you have to be a little bit more careful. Remember, for a sign to go to the power, it has to be in a parenthesis. So the sign does not go. 9 to the 0 gives you 1, but you still have a negative on the outside. In the next one, the 0 only applies to the end. It has nothing to do with the 3. So you have 3 times 1, which is just 3. The next one, the 0 is by the parentheses, so everything goes. Also the next one, everything inside is to the 0 power, so it's a 1. And the last one is also a 1 because everything is inside the parentheses.